Hi everybody, welcome back. I thought I would do this little preface at the beginning to let you know that this video is all about going through the schematics and really chasing down, most of the video anyway, that power limit circuit where it selects the two different power supply voltages based on the DC resistance of the speakers you connect. I'm going to just cut to the chase on this, a little bit of a spoiler alert for those of you who don't want to go through the length of watching this video with me. I think that anything except really high impedance speakers like the 16 ohm ones and so forth, it's always going to switch into low resistance mode or low power mode, because even an 8 ohm speaker is going to have roughly a 6 ohm DC resistance on it. That's just the way they're designed. The voice coils will typically have a lower DC resistance than their rated impedance. It's just the way a speaker works. And most 8 ohm speakers are going to have anywhere from a 4 to a 6 ohm voice coil, depending on the design of the speaker and many, many other factors. So I don't think there's a lot of times where this amp would actually switch into high power mode the way it works. The other thing is we chased the signals all the way around and learned kind of in pretty good depth how this thing works. However, at the end of the day, the adjustment still didn't seem to work the way that I thought that it should. Now, I could be wrong on that because I still am not 100% certain what they are looking for. And you'll see when we get into this that the instructions on this are just as convoluted as the receiver itself. It's not very easy to try to understand what they're telling you to do. And I even went on to Audio Karma, and it's funny, there was a little section on there on this particular amp with this exact alignment, somebody having a very similar problem. And I kind of only found this out after the fact. But it's funny, they arrived at the same conclusion I did, and that is that it seems that when you put your meter on one test point, you're actually adjusting the plot for the other opposite test point. That being said, I'm not sure if that's the way these are always supposed to work. So it could be that this still has some kind of an issue and that other persons also may still have some sort of an issue. It does work, and it does switch at that type of at that 6 ohm range, but none of the readings are what you would expect them to be. Let's just put it that way. So again, I'm getting long-winded here, but I just wanted to give you a little rundown on what this video is going to be. And if you're interested in seeing it or not, you may want to put it on high speed, speed up the thing. I don't know. But it was an interesting experience to go through all the theory. And I redrew some of the schematics and things, or highlighted some things to try to understand how it works. Because this is something unique. It's different than a lot of the other amps that we've worked on the bench here previously. So hope you enjoy it, especially those of you who like chasing electrons around schematics. We'll have some fun. So take care, everybody. Enjoy the video. Well, hello, everybody. I hope this video finds you all well. So part 2 here on this Technics or Technics SA-800 receiver. We're going to do the alignments just because I think it's kind of interesting, because this is different than a lot of the things you've seen on the bench here over the years. So I thought maybe this would be something fun to play with. Now, one of the things I wanted to do before I got into the actual procedure, which I have here, and you can see it requires a couple of 6.5 ohm resistors to set that trip point for when it goes between low power and high power amplifier mode. And they recommend using a 12 ohm and 15 ohm resistor in parallel. And no, they don't have to be great big power resistors, because really you're just setting that sampling circuit. We'll get more into that when we look at this a little more closely. But really, I wanted to know how this thing actually works, because this is something unique that I've not worked on before, and I'm always interested in circuit design and things that others come up with that I've never seen before. So you know me, when I want to understand a schematic, I try to break it down into its simplest form, isolate the different parts of the circuit, and then kind of study them in small parts. divide and conquer. That's how you troubleshoot, and that's also how you kind of reverse engineer things like a schematic. So let's do that. Okay, so here is what I've done is I've just took a breakdown of the original schematic. So here is kind of an enlarged portion of the schematic, and here is the whole schematic, and you can see how much stuff's on here. So I thought I would break it down into the part that I'm really interested in. Now, the first thing I found on this that I thought was really interesting is I said in the earlier video, in the previous video, that I did not think this thing had a overload or overcurrent protect circuit. And actually I was wrong. It's just the way they do it is a little bit different. Normally, as I showed you in the other schematic that from the phase linear, they'll put a transistor network in here that will sense the overcurrent, and then it will actually shunt some of the drive signal, from the input pair, and bypass the driver transistors for the voltage amplification stage. And that's how it kind of just clips the audio off, to reduce the output so you can never overdrive it. Well, this is a little bit different. If you look on here, let's see if we can zoom in a little more. You have this protect IC, which is pretty common. It's a 7071, and then they also have a DC overload protect that will drop out the relay to get rid of the, disconnect the speakers from the outputs. And so your input limiter, you see that right there, and it goes into this little integrated circuit. Similar thing to what the discrete component ones do on, for instance, the phase linear, but it's being done through an integrated circuit. So there is, in fact, a protect circuit here. So it has DC, it does check for DC at the terminals. So if you have a shorted transistor, it will pick up on that. It'll pick up the DC offset that you have on your speaker terminals, and it'll disconnect the speaker relay. And likewise, if this goes into an overload condition, reduces the amount of gain of this circuit so that it can't overdrive. So yes, there is a protect circuit, which kind of makes the enigma even more for me, because if this thing has the capacity to protect itself from overload and from offset problems on the speaker terminals, then why do you need to have two different power levels? Why not just let the thing run at full power all the time? And if something goes wrong, let this circuit do its work, right? But again, I'm just saying this out loud. If you have any answers in the comments section, please let me know. I'm always interested in kind of learning new things. So the biggest thing I'm interested in is the actual circuit down here that senses the speaker. It's not the speaker impedance. It senses the DC resistance of the speaker. There's a big difference on that. And so even though the impedance curve might not be flat, and most likely won't be flat, this only looks at the DC resistance of the voice coil, for instance, of the speaker. So if your voice coil, even though the speaker might have an impedance of 8 ohms at 1 kilohertz, the DC resistance of that voice coil, depending on the type of voice coil in the speaker, could be low, very low. And if it's very low, it's going to switch the amp into low power mode, even though it's an 8 ohm speaker. So I kind of just like it did to this my Klipsch speakers. So I want to take a look at how this thing works and how it does what it does. So here is, out of the service manual, a block diagram of how the power select circuit works. And I went onto Photoshop and I did, Paint, and I just outlined in different colors the different parts of the circuit, so it makes it a little bit easier to follow. So for instance, this section right here, this green section, this is the speaker select switches. So these are the actual push button switches right here that you push to select main and remote speakers, because you can have up to 2 pairs of speakers connected to this. So that's what these switches are. It's not a relay. And if you notice, there's more to these switches than just, main or remote. As you flip these switches, there's actually 3 different contacts on it. One set of contacts goes to this resistor network here. And if you notice, there's a voltage supply going into there, and I'm kind of looking up at my camera to make sure I'm in focus and everything. And what it does is, depending on what speakers you select, main, remote, or both, or none, each time you change that, you change the configuration of these 2 switches, and you change this voltage drop across here. So if you look, you have the B plus coming in here. It goes into these resistors to ground. All right. And so if this is a closed circuit, there's going to be 0 volts here. If this is an open circuit, then this point here will be whatever the voltage is coming through here. And if you have any combination, it will split that voltage between these and give you 2 different voltages here and here. And it goes into this little trigger pulse generator circuit, which is nothing but a monostable multivibrator. There's 2 of them. One of them is your actual timer, where, like, if you're going to drive the relay to pull in the speaker relay. So here's your speaker relay. This is what gives you that, I believe, what gives you the delay before it pulls this in. And then this one will actually trigger this anytime there's a change between these 2 switches. In other words, there is no one combination that won't trigger this. Every time you move these switches into a different position, no matter if it's one switch or both switches, it will cause this multivibrator to trigger. When it triggers, it'll pull the relay out, and it will give this circuit a chance to do its job, and then if everything's good, it'll pull back in. So it's kind of interesting how this works. Now, why does this mess all have to work like this? Well, what's happening is, here's your power amplifiers. So this is the actual amplifier circuits in the receiver, and these are the speaker outputs and that relay. If you look back here, circled in this purple color, you have the speaker DC resistance detection circuit. And all it is a couple of comparator ICs. And these comparators are connected to this little reference network. So to break it down a little bit, the non-inverting input of these is your reference. So you have a 1.5 volt reference. So basically, when you put the voltage up here, you have a voltage divider between these 2 resistors, and you're going to get approximately 1.5 volts of reference voltage there. Same goes down here, same thing. So for right and left channel, you have a 1.5 volt reference. Now, in addition to that, you have another voltage divider here, and it's a 3-way voltage divider, see it? And what's happening is, these voltage dividers here are going to be influenced by the voltage that you're setting up here with the speaker. So when this thing goes into this position, this relay, it pulls the coil, or the voice coil of the speaker, into parallel with point A. So it's kind of like just taking your speaker voice coil and putting it in parallel with this resistor right here. So you would have this in parallel with your speakers up here. That's going to affect the voltage at these 2 points. As this voltage changes, because when we change this voltage down here, it's going to change the voltage up here. It's going to change your actual sense voltage, we're going to call this, right here. And that's going to give you an output here. That output is fed down into the reference of the other channel too. More about this in a second. And then that will go in here. If the voltage is high enough, it will trigger this transistor, which will trigger this. They're just in a Darlington configuration, and it will turn the relay on. And that relay is what selects either the high power or the low power windings on the transformer. You see that? And then this will latch once it's in. Now going down to the actual schematic, the name of the game is we want to set it so that at 6.5 ohms of DC resistance at the speaker terminals, we're going to have enough voltage to overcome that 1.5 volt reference. And you're going to do that by adjusting this voltage divider down here. Remember, we have this three-way voltage divider that has our speaker in parallel with this bottom resistor. Okay, right here, I'm not on camera. This one right here. And you're going to do that by adjusting for each channel these two pots. You can see there they are. We're going to put a known resistance, which is where these come in, these 6.5 ohm resistors, and then we're going to adjust these until this circuit just trips. That's it. Okay, looking at this little diagram, they want us to connect 2 voltmeters, and strangely enough, they want the negative of the meter lead to go to the positive speaker terminal on the left channel, and they want the positive lead of the meter to go to the positive lead on there, and then the negative lead goes to TP601, which is right here, this little post, and the positive lead of this meter goes down to the emitter of TR613, which is right there. So you can see that's what we have. And then what they want is they want each of them to measure 13 millivolts. And you can see right now it's measured too high. The other thing is speakers switch to push position. All they're saying is they want your speaker select switches to be turned on so that the signal will get out to the speaker terminals. That's all. That's what they mean. So they want 13 millivolts on the meter. Now, strangely enough, when I connected this up the way they say, I'm actually getting a negative reading on here. So it is perhaps possible that they switch these around. So this they actually show it backwards. It doesn't matter on a digital meter like this, but of course, if this were an analog meter, it would be going backwards. Just a little side note. So anyway, the 2 pots that we're going to adjust is 602 and 601, and really all this is your idle current. And they want this thing to be on for at least 5 minutes, and I've probably been on for in excess of 10 minutes fiddling around with this. So I'm just going to adjust these 2 pots till we get 13 millivolts on each one. So let's see. Well, that changed it quite a bit. So being a one-turn pot again, these are that's pretty good right there. How's that? And then this one's a little bit high. But again, you barely have to touch it. I'm going to leave it at 14 because that's about as close as you're going to get. And then we're just going to let it sit for a little while, and it'll probably drift up and down a couple of millivolts. It doesn't really matter. But that's it. The bias is set. Okay, our next section here is the power level indication alignment. Connect an AC VTVM. So obviously they want a high impedance on the speaker terminal. Now we can use the fluke meter because it has a very high input impedance as well. And what they want is power display switch to on position. And they want the range set to times 0.1. They want the selector switch to auxiliary. They want to apply a 1 kilohertz signal to the auxiliary terminal. And then they want to set the volume control to the maximum position of set. So we're going to turn the volume all the way up, and then we're going to use the signal level of the signal generator until we get 12.6 to 12.7 volts output at the speaker terminals. And of course, if we do the math, let's just say it's 8 ohms. If we take 12.6 squared and divide that by your 8 ohms, they're saying about 19.8 or about 20 watts. So they're saying if you times that by 0.1, so it's going to read the 200 on the display. So if you look at the display, it goes from 0 to 200 watts. 200 watts times 0.1 is 20 watts. Hence the reason they want it to read 200 watts, because it's times 0.1. So really we want to set this so that you would get a theoretical output of 20 watts into 8 ohms. And that's how the math works out for it. Now, again, in the typical form for this design of this receiver, you have to take the light spreader for the dial completely out and get it out of the way, because the pots are right here, and then there's an access hole here through there for the other channel. Okay, let's turn this on. We're connected to the speaker terminals. Let me turn the volume the whole way up. Let's turn on the signal generator, which it's on already. And I'm feeding about 50 millivolts into the input, so it's a little bit low. So let's turn our signal level up. There's 60 millivolts, 61, 62, 63, 63, that's about it. 12.64, that's pretty close. So that's right in the middle. That'll give us our 20 watts. And essentially, what we should see is we should have, we reading about 200. And it's going to be kind of hard, but let me see if I can get the camera. And right there is it's saying 120 here, and it's just barely edging onto 200 here. So this one's pretty close. This one's out a wee little bit. Okay. I don't know if you're going to be able to see this. I'll try to turn some lights off to make it a little easier. I don't know, can you see in there? We want this next one here to light up, and we want this one to be totally lit up. So let's start with the right channel. Let's see if I can adjust this. That is the wrong way. And there it is. And I just kind of want it to be right there. Now let's do this one. I don't know if you can see it or not. I just don't want to take the camera off the stand or anything here. Wrong way. And there we go. So it wasn't that far off. It was pretty close. I just had to turn this just a little bit. And there it is. So the power meter indicators are now functioning. Hopefully you can see them now. There they are. Both at 200. Okay, before we move on with this, I'm going to do what I should have done previously, and that is to check this thing for any kind of DC offset at the speaker terminals. Reason I say that is there is no offset adjustment on this. There's no DC balance control. It's all up to that input pair, which on this is this dual transistor packet. And this would happen to be, what, TR602 and TR601. And 601 and 602 are those two SA-979s, which those can be problematic. So let's see what we have. It's definitely not going to be 1 or 2 millivolts, but because it's not adjustable. But okay, so you have negative 18 millivolts on the left channel, and you have negative 24 on the right channel. So I guess that's not the end of the world. That's not bad. Not going to hurt anything. All right, let's get back to our original problem. Okay, the very first thing it says here is the resistors we're going to use must be of low tolerance, plus and minus 1% to 2%. So they want it to be pretty accurate, and I really have not measured these resistors, and I don't know how close they're going to be, but we can fix that real quick. And let's see how bad I am. So these should be about 6.5 ohms, roughly. There you go, 6.576. That will be good enough. And let's see what this other one is. Hopefully it's the same. .579. So yeah, they're very close. So that should be enough. That should be close enough. Close enough for government work, as they say. These, I don't know if you've ever seen these types of speaker terminals, but they're kind of weird. Adcom, I think, has a similar thing where they're like half turn, or might be Kenwood. These are totally different than that, a little bit different than that. Whereas you put the wire, and it can't be frayed. You have to get it in there all the way till it bottoms out. Then you tighten this, and it clamps in on the wire. I don't know if I like that or not. You can't get a very big diameter wire. So those of you who like the 400 MCM mains lead oxygen-free, kissed by Vestal Virgins $30,000 speaker wires, you're going to be disappointed on this. So, but it will hold just a plain 12 gauge thin stranded wire. Okay, for starters, they only want the left channel to have the resistor on it, so I removed this one. Got to really read this 2 or 3 times because it's a little bit confusing what they want you to do. They also want an oscilloscope on TP1 and chassis for the left channel. Between TP3 and chassis for right channel, set to voltage measurement range. Now, I'm not sure why they want a scope here, so maybe there is going to be some kind of a waveform. I don't know. I can't figure out why they wouldn't just want a regular voltmeter, but it doesn't say anything about a waveform or anything. So, it doesn't say to look to any, yeah, I don't know. So let's turn this around and get the oscilloscope connected. So looking back at this whole situation, let me get the camera in a better angle here and zoom in. What they're telling you is to set the, I'm going to shut this off. Set the volume to minimum, we did that. Connect a scope from TP1 for the left channel or TP3 for the right channel. And TP1 and TP3 just happens to be these two, I don't know if you can see them here. TP3 is right here, TP1 is right here, and then here's IC902 and IC901. Those actually look like, you know, those 5-pin transistor pairs, but they're not. They are op amps. They are 5-pin op amps. So the adjustment for this one is these 2 pots. And the adjustment for this one is these 2 pots right here. And the other 2 test points that you're supposed to jumper to ground is TP2, which is right here, and TP4, which is right here. And let's look at all this on the schematic. Because what they're doing is they're telling us to connect the scope on one of those 2 test points, depending on which side you're aligning. Connect a 6.5 ohm resistor. So you just want to force this thing into low resistance mode. short TP2 and TP4 to ground. And what you're doing, there's TP2 and right there's TP4. Let's go in a little further so you can see better. All right, kind of rushing through this, but so TP4 is the transistor base that pulls in the relay that's basically your speaker protect relay, or also your sample relay. So this relay toggles between connecting the speakers to the amp and connecting the speakers to the sample circuit. And this just disables this from ever coming out of protect mode. So it just forces it to stay connected to sample mode. This one here, if you follow it all the way through, and it took me a while to figure this out, it goes down through here and it comes up into the monostable multi-vibrator circuit. And all this is doing is this is stopping this thing from pulsing the relays on and off. So you're basically taking the relays out of the circuit and just allowing you to make your measurements here on the op amps. Here's your two op amps, and here is TP1 and here is TP3, and those are both the outputs of the two op amps for right and left channel. And again, like I said, they kind of cross feed one another. So one channel will affect the other. So I think it's important what order we do this in, and we follow this to the letter. But where I'm at right now is this whole thing about 0 and 6 volts. Okay. I don't know if what they're saying is just that you make sure that it's between 0 and 6 volts. I think that's what they're trying to say. As long as you have anything between 0 and 6 volts, you're okay. There is no possible way that you can have a waveform on here. It's an oscilloscope. They might have you do a scope, but I think the only reason they're making you use a scope is so that you have a high input impedance and you can actually monitor the test point as you're adjusting it. I don't know. So then you're basically going to set these for their low state. Then they want you to go over and remove these resistors and take the shorting wires out. And then they want you to connect 6 ohm speakers to the speaker terminals and confirm that TR613 collector voltage is 10 volts lower than the voltage measured in item 8. So you're going to measure the collector voltage at 8 ohms, then put a 6 ohm speaker and measure it, and it should be 10 volts less. I don't know. I'm not getting any kind of anything. The only thing I get is when I first turn it on, I get a little spike. But I think the spike is just because the op amp is powering up and stabilizing. So really, I don't think you're looking at anything there. So this is obviously proves that their service manuals are just as convoluted as this weird, unnecessary circuit in here. Sorry, folks. Any of you who like these things, I can't share your love for it. But anyway, let's see if we can get it to do something. Okay, well, this happens to be the dumbest thing I've ever seen. But hey, stupid is as stupid does. Is that what they say? So you put your meter or your scope, whatever you want to use, on this test point here, for instance, which is TP3, but you adjust the pots on this side. In other words, these two pots control this test point, and these two pots control this test point. They're opposite of what you think. And the service manual does not say that, because it says adjust 901 and 902, which are these two pots, for a voltage at TP3. See that? 901 and 902, so that TP3 output, that is not true. So you have this threshold setting, and you can see right now I have both speaker jacks out. Now I have, just so you know, let me turn this around. I don't know if I can move this. See what I have? I have my 8 ohm dummy load resistors on the main speaker terminals, and I have these 6 ohm resistors on the remote speaker terminals. So with no speaker selected, this is what we would call high power mode. In other words, if this goes high, that's low power mode. If this goes low, it's high powered mode. It's not going to operate any of the relays right now because we have the relay activity jumpered out with these two wires. That's what they're trying to do. So when I put in the remote, the 8 ohm load, nothing happens. See that? I'm pushing the 8 ohm speaker load right here. See that? Let me move this so you can see the whole thing. So there's nothing. See if I can get this out of the glare. And if I turn on the remote, it should switch. And it doesn't care how it switches. It just wants it to be somewhere between 0 and 6 volts. All right. So it's 3.9 volts, which is between 0 and 6. So it's good. So let's turn this back off. And let's play around with the adjustment right now. If I turn remote speakers back on, and I adjust the pot here on the other side, which is right now I'm on VR904, you can see I can move it until it triggers. Now it's not set properly. So I'm just going to turn this counterclockwise until it trips. See that? Now watch, if I turn this off and back on, it's not tripping. See that? So I don't have it adjusted enough. So let's move it a little bit more. And there, now it kicked. So let's turn it off and back on. Now it's working reliably. See that? Okay. Good. Let's now move the meter to the other test point. And now we're going to use these pots on this end. Okay. So I'm going to again turn this on, and this one works. And you can see this time it's 5.5 volts. And really both pots have like a range in which it'll kick in and out. Okay, this first pot doesn't do much of anything, this VR902. VR901, however, let's see. It's not working at all. Great. That's pretty awesome. So this one is not even functioning. So maybe I have to move both of them till they get to a... Nope. And I have these marked so I can put them back where they were. So the pots on that side have very little effect, and it's probably because I'm not doing this in the sequence they're saying. I think they want you to disconnect the resistors from the one side and only connect it to one side at a time. So let me pull one leg out of each one of these. Let's see. There we go. And that, I just removed the left channel. And now it doesn't do anything. This is a really goofy adjustment, I'll be honest. Okay, so now it does nothing. It's always off. So let's put that one back on and take the other one off. Hold on. And when I switch this, now it triggers. So let's see if now we can get it to go on and off, because I have the resistor of the left channel disconnected now to see if this pot will adjust. Okay, that pot is not doing anything. That pot is not doing anything. So let's turn both of them fully clockwise, and I'm getting nothing. So let's turn both of them counterclockwise, and I'm getting nothing. So basically, the adjustment for that channel does not work. So let me turn this off. Let's connect a scope up to dual channel, and so we can look at both sides at the same time, and let's see how all the pots interact with one another. Okay, I have the scope set, and these are both set to 0 volts, both channels, so we can look at the two channels individually. This is this channel, and this is this channel. I'm going to turn the amp on now, and I don't have any speaker selected. I'm going to first select the 8 ohm load, and you can see nothing happens. Now I have no load selected. Now I'm going to select the 6.5 ohm load, and you can see they both go high, which is what they're supposed to do. So it's working. We just don't know to what degree it's working. We know that at 8 ohms it won't trip, and at 6.5 it will, but we don't know in between exactly where we are. But I can get the one channel to toggle. So if I move this first channel here, actually that one pot triggers both of them. So R904 seems to adjust everything, and the other ones have little to no. There we go. So there's like a range on R905 where it'll kind of make it weird. See that? Okay, let's adjust 901 and 902 now and see what they do. I don't think they're going to have any effect at all on anything. So I don't know if there is a bad resistor or a bad component. Maybe one of these op amps is not good. I don't know. But we can certainly, I can't think that the op amp is bad, because each op amp changes its output. So you can see when I go between these, the two op amps do trigger. But the one thing that concerns me is, notice this channel right here, it goes to 2, 4, it goes almost all the way to the rail. Whereas this one goes only to about 4 volts. So I'm wondering if this particular op amp is shorted or something, and it's just passing the signal through and not really amplifying anything. Now, if that's the case, I don't have one of those weird op amps to replace. I suppose we could try injecting some signals to see if anything's changing, but all I can tell you right now is that's definitely not right. So looking down inside there, I am on pin 1 of each of the op amps with my scope, with each channel. Now moving back up to our screen, if I turn the amplifier on, hold on, and I click the button, you can see I get that one moves. Let's center these two traces a little bit so we can see them better. Come on, dirty control. So you can see that one moves. So this channel right here moves when I adjust the pot. See that? The other one does not. And I can't really do anything to change it. Let's see if I can adjust it by tweaking any of these pots here. See, it's jumping. When I cross through that little threshold there, it triggers on VR904, but that's all it does. And this one here. So really, we're not really adjusting much of anything on there. That's pretty strange. So we're looking at pin 1, which is supposed to be your feedback line. And obviously, of course, it's going through some really high resistances. Well, not really high, but high, 10K and so forth, and a 12.7K. But that potentiometer isn't really, well, it shouldn't adjust anything, because all we're adjusting is, okay, I get it. All right, let me get you down here. Hope you guys are interested in this. This is just me troubleshooting, so I'm not teaching right now, I'm learning. Okay, so I was testing right here, pin 1 and pin 1. But if you look, the pots don't affect pin 1. The pots that I'm turning affect pin 2. So really we need to be on pin 2 to see. So really we're adjusting the reference on the op amps, not the input. We're not attenuating the input, we're adjusting the reference, which makes total sense. So that was a stupid Tony thing. All right, so let's move the probes over to channel 2. Or I'm sorry, to pin 2 of the op amps. Okay, I'm now connected to pin 2 of each of the op amps. And if I adjust, let's start at VR901. If I can get the tweaker in there. You can see VR901 is moving this one ever so slightly. See how, just a tiny amount though. I'm wondering if one of these is more of a coarse adjustment and the other one's a fine adjustment or something. Yeah, see, that one moves it a lot more. See that? That's a coarse adjustment, and the other one seems to be a fine adjustment. Okay, so that moves that side, and I would imagine this side's working as well. Yep, see that? There's your coarse adjustment. And this one's probably the fine adjustment once again. Yeah, it just moves it a wee little bit. So that's what those are. That's just a coarse adjustment and a fine adjustment for that. And they are both moving, but we are never getting, you're never getting a change on the output of that op amp. So I have to say that one of those op amps is actually bad. So adjusting these two pots, they kind of act like a coarse and fine adjustment. It will adjust this signal here. Now they want these to be 1.5 volts roughly is what those are supposed to be, but they can be slightly off of 1.5 volts because it just depends on all the circuitry in there. If these resistors are a little bit out of tolerance or something, that allows you to compensate for it with these pots. So as the name of the game is, you want these to balance so that you don't get an output, and then when you do trigger it, it just needs to be 6 volts or something. 5 volts, 3 volts, enough to trigger this whole circuit and to activate the relay. That's really all we care about. So it doesn't have to be a precision calibration. It just has to be a 1 or a 0, pretty much. I think the reason that there's a big disparity in the two voltages is because, once again, going to the block diagram, let's open this up more. Going to the block diagram, you have these are sharing. So the output of this one, of 902, feeds up into the reference of 901. And the output of 901 feeds into the reference of 902. See that? They affect one another. So I think what's happening is one of these ICs is shorted somewhere internally. And all you're doing is when you're toggling the one IC, this one's appearing to toggle as well, because you're seeing that 3.9 volt output as what's coming through here and looping back through. That's what I think's happening. I think we have a bad IC on this. And I think that might be somewhat why this thing's not working properly, I don't think. Okay. So here is R928 and here is 916. And these are the two resistors that go in parallel with your speaker load. Now I have that 6.5 ohms connected to the right and left channel on the remote speaker switch. So if I leave this out, this should be a higher voltage. When I push the remote speaker select in, these should both go to a lower voltage. So let's start out with R928. So here's 928. If I can find it. 928, there it is. And if I read it, it's got 232 millivolts on it. See that? And if I select the switch, it drops to 30 millivolts. That's what I would expect, because you're putting that 6.5 ohm resistor in parallel with a, what is it, a 47 ohm resistor. See that? So you're dropping the resistance, you know, massively. Now if I go over to R916, and there's your 235 millivolts again. If I switch that one, it doesn't work at all. Nothing. So I'm not seeing my speaker load on that particular channel. So it may not be a bad op amp. So let's turn this off for a minute. So R916, which is right here, is not reading through relay 601. And relay 601 is this one right here. And technically, I should be getting something through that. And if you remember, I checked these relays and the contacts measured good on them. So that's your protect relay. No, I checked the protect relay is the one I pulled out. And it checked good, remember? It's testing good. It's perfect. So somewhere along the line, I am not getting any signal. And this one here is going through there, up to that. And this one here is going there, up to, oh, I'm sorry, to here. Right there to the switches. So really the only things it can be, because we have this path here, to here, to here, up to here, and over here. So we have to have a bad switch in there, don't you think? That has to change. It's not changing. So let me spray that switch like a cat in heat and see if we can get something to work. Okay, so I have my 6.5 ohm resistors on speakers B, or remote speaker, whatever you want to call it. And I am going to measure from ground, let's see here, from ground to, well, to the speakers up here. We're just going to see what this looks like. So I'm going to look at one end of the relay and then the other. So if I go down here, there's my 47 ohm resistor that's in the op amp circuit, in that voltage divider. And if I select the remote speaker, it goes down to 6 ohms, which is the 6.5 plus all of the other resistance in the wires and things in parallel with that 47 ohm. See? In and out. See there? If I go to this side, this is the other channel. Same thing. See that? All right, now I should be able to go to the normally closed relay contact because this thing's not connected in any way. It's not plugged in, powered up, anything. And if I go here, I should see the same thing essentially. And I do, see that? If I go to this side, see that? It's jumping all over the place. I have a bad contact on that relay, and I tested it. I tested that relay. It measured okay. But there must be a bad spot on it or something. I have to take that out and check it again. Okay, well, let's see what we get here. If I go from here to here, it's good. And again, I'm not using the Kelvin leads or anything. It's good. So why did it not read like that in there, unless I got a weird solder joint on there or something? But that relay's reading okay. I mean, it doesn't seem to be reading incorrectly. It looks good. I'll try it again. Let's see. Good. Good. I mean, you can see this one that was reading bad in there is slightly, well, not really. I get the leads on there good. It's okay. I don't see anything wrong with this relay. But you clearly saw in the circuit, it was not reading right. Now, I don't know if maybe there was a cracked solder joint. I don't think. It looked good. I mean, you saw it in the video. I'll give it a little bit of a closer look, but as far as I can see, everything seems to be all right. So now that with that relay out of circuit, I'll connect back up to my ground, and again, I should be able to see I have nothing there, and then when I go in, when I click, there's your 6 ohms, which is what you should see. And when I go up here, I'm not reading anything because there's no relay in there connecting those together. Yeah. I don't know. It's a mystery. Okay, let's see if this is reading better. So this one was the one that worked originally. And am I on it? There we go. And it's switching. Very good. This side. Perfect. Okay, so what I did was, in addition to, I did clean the contacts a little bit. I just sprayed them with a little bit of the electromotive. They really weren't dirty. I mean, it just, you saw the contacts, they read okay. But I also scraped back a little bit on these pads and flowed the solder up onto the pads a little further, onto the traces. Maybe there was a tiny little crack on there or something. I don't know. Now, we still have to go around to the other side and see if it is getting over to those resistors now, because we weren't seeing it there either, of course. I just want to make sure that everything is good. Okay, here's R928. And that's good. That's what we want. And then R916 is going to be up in here. Can't remember I remembered the number. Can't believe. Okay. Now I'm getting it. See that? Okay, let's go back and try to do our test again. Okay, we're hooked back up for our original test. I am back on TP1. I have my 6.5 ohm resistors connected, but they're out of circuit right now. So it's set to no speaker selected. I turn it on. I get nothing on TP1, and I get nothing on TP3. Okay. Let's switch in the speakers. And look at that, I get 5.5 volts. Okay. Let's see if we have some adjustment on this now. Yes. And the correct test point goes with the correct plot now. See that? All right. So I have a feeling if this thing reads backwards, it's because there's one of the two signals is not getting back. And this is not making any difference at all because, like I said, this is a coarse and fine adjustment. So put that back there. All right, so that one's good. Let's go over to this side. Well, now it's a little bit weird. Okay, it's 3.9. Let's see if it's adjustable now. Well, maybe these pots are still backwards. Let's see. That one, those aren't doing anything, so we're back to where we were. It worked for a second. Back to no worky. I'll put the pots where they originally were. But it worked for a second, and now it's not working again. It's back to doing, now it's not tripping. Look at that. Okay, hold on. Let's see if this adjusts it. Yes, it does. So it's back to how it was. It worked one time. I had that when I first turned this on. I swear I saw the 5 volts on that side as well as this side. See, that's 5. That's what it should be. But I don't have it on the other side now. Again, it's 3.9. But again, maybe that's the way it's supposed to work. Let's put the 8 ohm load on and compare. Okay, so I have 8 ohm dummy load connected to speaker main and the 6.5 ohm resistors to speaker remote. I turn this on. I have both of them out right now. If I put the 8 ohm load in, nothing changes. See that? If I put the 6.5 in, it changes. See that? And if I put both of them in, it stays on because now it put the two speakers in parallel. So that's even lower than 6.5 ohm. Okay, let me turn this off. I still think there's something weird because that TP3 at one time went up to 5.5 volts, up from that 4 volts. It matched TP1, but I might have been imagining. I don't know. All right, so this is all off. Let's see what the relays do now. And I'll put the microphone down here so you can hear everything going on. There we go. Hope you can hear it. Okay, so that was the protect relay coming in, the speaker relay. 8 ohm load. Did you hear it went tick tick? And you can see this stayed low. That tick tick is that multi-vibrator circuit giving that one shot to put it in test mode for a split second. Now let's go to the other load, the 6.5 ohm. And there it is. You can see that's pulled in. And you can see this is 5 volts now. It's not 3.9. I told you. Okay, let's go over to this one. I'll be interested to know if it changes. And that's 5.5 still, but this one is 5 volts now. It was 3.9. You saw that. So let's come back out. Go back in. It's 5 volts. And let's put the 8 ohm load in. Nothing. Perfect. That's what it's supposed to do. Okay. So now I'm going to, I have the speaker all deselected. I'm going to move over here from the dummy load to my speakers once again, to my clips. And I doubt that this is going to make any difference. But let's see. Okay. Go back down in here. And I just realized the microphone's down there, so I'm probably pretty quiet. You're not hearing everything. Here we go. This is the 6 ohm load. Here's my Klipsch speakers. See, it's still going into still going into low power mode. So let's just, for the heck of it, let's just look at what our speakers are in DC resistance. All right, let's see how they measure here. I hope this doesn't fall while I'm doing this. Well, would help to put it on ohms, huh? 4.25 ohms, that's why. The DC resistance of those Klipsch speakers is 4 ohms. So, even though they're not rated as 4 ohm speakers, of course, again, it's impedance versus DC resistance. And it is strange because most 8 ohm speakers have a voice coil of around 6 ohms or so. It's always a little bit lower than the actual speaker, impedance itself. So to me, anything except like really high, like old-fashioned 16 ohm speakers is always going to be switching this thing into low power mode, which doesn't make any sense to me. So it is what it is, I guess. I don't like this design. I don't like the way that works, but you folks saw it. It just is what it is. So maybe the only reason that has that higher voltage is so that you can get full power at, with old-fashioned like 16 ohm speakers, not 8 ohm speakers. I still think that's kind of crazy, but that's the only explanation I can have for this. It is working. It is doing what it's supposed to do. I don't know if I just went on a wild goose chase on this or I actually fixed something, but we did not have the resistance at that R916, and now we do. So it is, both channels are now affecting it, but if you saw when I adjusted the pots, it still didn't make any difference. So I don't know, did I fix anything or not? That's pretty much it. I'm done with this thing. It works. We can play some music through it, but you've already heard it. Everything works on it. It's just not my favorite design. So I'm going to button it up, and I just don't want to waste any more time on it. I don't know if this will unseat the NEC A11 for the Janky Award, but if not, it will be a close runner-up, in my opinion. All right, everybody. If you're still here, thanks for going on my wild goose chase with me. And I wish you all peace, joy, happiness, and good health in your lives. And hope to see you again real soon here on the next video. Take care, everybody. Bye-bye.